Hey everyone, welcome back. I hope you're doing well. In this video, we'll walk you through the sequencing process using a sample sidewalk project. In this example, you are given the following packages and activities. Your task is to develop a complete sequence of these activities. Please note that the current order shown in the table may not represent the correct sequence. Also, this is not a full list of activities. These are just examples of main tasks for illustration purposes. In a real project, additional activities, such as mobilization to bring equipment and materials to the site, would be included before construction begins. Again, since this is just an illustrative example, we're simplifying the process and not considering every detail to save time. As you can see, our project is broken down into 4 work packages. 1, site preparation, 2, formwork and rebar, 3, concrete work, and 4, finishing. Each work package consists of several activities. For example, the first work package, site preparation, involves 3 tasks: laying out the area, removing the topsoil, and excavation. We'll go over the details of these activities shortly. Similarly, we need to complete other tasks to finish the remaining 3 work packages. The second package, which focuses on formwork and rebar, consists of 2 activities: installing the formwork and installing the rebar. The third work package is concrete work, which involves 3 activities: pouring the concrete, finishing the concrete, and cutting edges and center joints. The final work package is finishing, and it includes just 1 activity: removing the form. In total, there are 9 tasks. Now let's figure out the possible sequence of these activities. As you may remember in the previous video on determining construction logic, we learned 2 methods for developing an activity sequence. The first method begins with the activity that has no predecessors and progresses forward, while the second method works backward from the final activity. The first method is more commonly used, so we'll be using it for this example. We begin with the activity that has no predecessors and identify which activities need to come before others. So the first step here is to identify the immediately preceding activities, IPAs. Let's start with activity 1, lay out the area. This activity involves marking the area where the sidewalk will be constructed, setting the boundaries for the work. Since this is the first step, it has no immediate predecessor. Next is activity 2, remove topsoil. In this step, the top layer of soil is stripped off to prepare the ground for excavation. This activity depends on the layout being completed to ensure accuracy. Therefore, activity 1 is the immediate predecessor, linked by a finish-to-start FS relationship. Activity 3, begin the excavation, involves digging out the soil to the required depth for the sidewalk. Excavation can only start once the topsoil is removed. So, activity 2 is the immediate predecessor with FS logic. Moving on to work package 2, we have activity 4, install the formwork. This step involves setting up wooden or metal forms to shape the concrete. Formwork installation can only happen after excavation is completed, making activity 3 its immediate predecessor with FS logic. Activity 5, install the rebar, involves placing steel reinforcement inside the formwork to strengthen the concrete. This step requires the formwork to be in place. So activity 4 is the immediate predecessor, connected by FS logic. Now, activity 6, pour the concrete. Fresh concrete is poured into the formwork over the rebar. This step is dependent on the rebar installation. Thus, activity 5 is the immediate predecessor with FS logic. Next, activity 7, finish the concrete, involves smoothing and finishing the surface of the freshly poured concrete. This activity must start while the concrete is still workable and finish as the pouring completes. Therefore, activity 6 is the immediate predecessor with both start-to-start, SS, and finish-to-finish, FF logic, meaning finishing work starts with pouring and completes on the same day. After finishing, we move to activity 8, cut edges and center joints. This step helps control cracking by cutting joints into the concrete after it is set slightly. Cutting can only start after the concrete finish is complete and must wait for some curing. So, activity 7 is the immediate predecessor, connected with FS logic and a 1-day lag to allow proper setting. Finally, activity 9, remove the formwork. The forms are taken off once the concrete gains strength. This also depends on the completion of concrete finishing and some curing. Hence, activity 7 is the immediate predecessor, also connected with FS logic and a 1-day lag. Alright, now that we've logically identified the immediate predecessor for each activity, let's move on to step 2, where we use this information to sequence the activities within each work package and develop the complete project sequence. In step 2, you need to sequence activities based on the IPAs identified in step 1. You begin with activities that have no predecessors. In this case, the first activity is activity 1, lay out the area, which falls under the first work package, site preparation. When using sticky notes, you write each activity on a separate note, using a specific color like yellow. You can use different colors to represent different work packages for better organization. The next activity in the sequence is Activity 2, remove topsoil, as it is the successor of Activity 1. Similarly, the next one in line is Activity 3, excavation. Moving on to work package 2, formwork and rebar, we got Activity 4, formwork installation following directly after Activity 3 of the first work package. Then we have Activity 5, install the rebar coming next, as Activity 4 serves as its IPA. Here we use green notes to distinguish these two activities from the previous work package. Next, we proceed to work package 3, concrete work. We got Activity 6, pour concrete, preceded by Activity 5 from the second work package. Then Activity 7, finish concrete, which depends on Activity 6 through two logical relationships: start to start, SS, and finish to finish, FF. In other words, these two activities run almost concurrently. After this, we got Activity 8, cut edges and center joints connected to Activity 7 through an FS logic. Finally, we move to work package 4, finalization, which consists of a single activity. Activity 9, remove formwork. This must follow Activity 7, finish concrete from the third work package. Now that we have identified the sequence of activities within each work package, we can proceed to combine them into a single sequential flow for the entire project. In this final step, you connect the partial sequences of all individual work packages to form a complete sequence. At the activity level, the sequence follows this order: Activity 1, Activity 2, Activity 3, Activity 4, Activity 5, then jumping to Activity 6. Activities 6 and 7 are concurrent, meaning they must occur simultaneously. After Activity 7, the sequence continues with Activity 8, and then Activity 9. As you can see, most activities follow a linear sequence, progressing one after another except for Activities 6 and 7, which run concurrently. To accelerate the project, you can switch from FS, finish to start, to SS, start to start, where possible. For example, in work package 2, you start rebar installation once part of the formwork is in place, allowing the tasks to overlap. However, you must ensure sufficient workers and equipment are available to handle both tasks simultaneously. In cases where you want to represent the sequence at a higher level, the work package level, you can simplify the details by grouping activities within their respective packages. This results in the following sequence: work package 1, work package 2, work package 3, forming a straightforward series. For the final work package 4, partially overlaps with work package 3 because Activity 9 from work package 4 can start simultaneously with Activity 8 from work package 3. This dependency is modeled using a start-to-start SS relationship with a lag equal to the duration of Activity 7, finish concrete. This high-level sequence provides a broad overview for project managers or clients, supporting in high-level decision-making. Alright, that concludes this video where we've walked through the process of sequencing activities for a sample sidewalk project. Thank you for watching, and we'll see you in the next video. Goodbye.